Okay, part 3ers. The next one's an ellipse. So we reviewed this when Alex was reviewing, so I'm not going to tell you step by step. I'll show you the answer. This is what you'll get on the final and asked to graph it. So you will, first of all, put the constant on the other side. Verify that. And then you will group your x together, y together. Then pull out the lead coefficient, 9 for x, 16 for y. And then complete the square. This becomes half of 16 squared, half of -4 squared. So that's really a 9 times 64, so I have to add a 576. And that's really a positive 64, so I have to add that. So these all add up to 144. So now I create the perfect square from this and this, and it equals 144. To graph the ellipse, this has to be a 1, so I divide everything by 144. And 9 over 144 and 16 over 144 reduce. And here I'm ready for graphing. This holds the secrets. Hector and Kyle, -8, 2 is the center. And this is a squared, this is b squared. A squared is the longer, and we want a is 4, b is 3. We're interested in recognizing that when the longer one is under x, it's a horizontal ellipse. So we're going to graph this point and go out 4 on each side, and then we can go up and down 3. So this point was -8, 2, so 3 down and 3 up. So we have this ellipse. All right. And they wanted the vertices, so if we were at -8, what does that say, 2? So if we go out 4 this way, that was my A, and 4 that way, it'll get us to these 2 points, which are the vertices. So you'll see that answer on the sheet. I think it's D. Then we have to graph a hyperbola, so I did the work for you. Again, there's the general form. We have to put it in standard form to graph it. So I'll run through that quickly. Gather y's and gather x's. And now you want to complete the once you gather the y's, they're ready to complete the square. This one you have to pull out that -16. Being careful to note that that creates a -2 in here, so that a negative times a negative is a positive. And we can complete the square, 1 here and 1 here. Adjusting for it, we add a 1 for that one, we add a -16 for this one. And 31, 1, and -16 are 16. And we have this completed the square, and equals 16. Divide everything by 16. And we are almost ready here. So simplifies to that. So this is like a 1 under here. We graph this by doing an x. Well, first of all, we recognize the center is -1, -1. Or 1. Oops. What is that? -1, -1. Okay. Alright, so the center is -1, -1. And because of Hector and Kyle. And then the graph, then we're going to graph as if there is no Hector and Kyle. And we drop those for graphing, and we recognize that when x is 0, y is plus or minus 4, that's a real number, and when y is 0, x is negative, x squared is -1. Square root of that is imaginary, plus or minus 1i. So I'm going to find the center. -1, -1. Oops, I went up. -1, -1 right there. And this little exercise from here, I'm going to go up and down 4. 1, 2, 3, 4, and down 4, and over 1 and both sides. Create a box. Put in the diagonals. And the hyperbola is either going to go like this or like this, but we know it's not going to be on the imaginary spot, so it's not this way, it's going to be this way. Alright, so after that one, we're going to go ahead and, mine is all patched up. Yours is a nice copy. We're going to solve this logarithmic equation, and they're both base 4. When there's 2 logs on one side, you have to get that so it's 1 log. So I'm going to combine these by log rules. When you have 2 logs subtracted, you can take the arguments and divide them. And now I want to get rid of the word log, so I go to exponential form. 4 to the 1/2 equals x over x minus 1. So this number raised to this equals that. And 4 to the 1/2 is the square root of 4. Multiply both sides by x minus 1. Move the x to one side and the numbers to the other, and I get x equals 2. Check the arguments. 2 minus 1, that's positive, so we can accept it. X equals 2. The next one is graphing. This will be on the non-calculator part of your test. And this is case 2, when the degree of the top is equal to the degree of the bottom. When that's true, the vertical asymptote is figured out the same, so that would be x equals 1 would cause the bottom to zero out. The horizontal, however, is going to be the lead coefficient on the top divided by the lead coefficient on the bottom. -5 divided by -1 is y equals 5. So now we expect slashes this way or that way. So I'll just give myself 1 point. If I put in x equals 0, I get 1 over 1. So 0, 1 is on this graph. So that tells me the slashes. That's supposed to go through that point. Slashes are like that. So you will have to graph case 1, 2, and 3 on the non-calculator part of the final. We didn't have a test on that, so that will be prevalent. Alright, last 2 or 3, 4, right, on this one. One of the things that will happen on the final is I'm going to give a parent function that is somewhat altered by a number transformed, and so you're going to have to graph it and answer those questions like you did on your project. So we are recognizing that as absolute value, drop down 2, so the graph looks like that. So let's answer those questions about that graph. Domain, what values of x can I go up and down and still hit the graph? Well, since this gets infinitely wide, at some point it's going to be all reals. And the range is the values for y. Will this value for y ever touch the graph? If I go to the left or right, will this value for y be in the range? No. Will this one? No. This one? But once I get to y equals -2, I will be in the range, and so will all the values above it. Even means I go out this side and this side, and I get the same number. And I do. So this is even. X-intercept, it crosses the x-axis at -2 and +2. It crosses the y-axis at -2. It is decreasing, so if you're the little cart, it goes from left to right. It's going down, so it's decreasing from from -infinity. These are always in terms of x, so we're going to go out all the way to -infinity and start there and then go to 0. This is interval notation, and that's where it's decreasing. Then it starts increasing. So it's increasing on the interval 0 to +infinity and doesn't have any constant sections. Symmetry, it's symmetric to the y-axis. And relative max or min, it's got a relative min at